would like to present my Capstone 2 project. So my Capstone 2 project is about the roadside classification for the traffic side in the United States. So the content of this presentation is we're going to go through background, the data set that I am training, and then we're going to doing some EDA on the data sets. After that, we're going to build a convolutional neural network, as well as we testing the model with the real world image. And then the final step will be like how to optimize and what is the next step um, to improve my model. And yeah, so let's dive into the first slide. So the background of this project is the traffic side is providing a critical information for the driver, and then is requiring them to um, behave their driving behavior, and make sure that they are following the roadside reinforced the road regulation. But it's also very important for autonomous vehicle because the vehicle must also be able to recognize and understand the traffic side to follow the road regulation as well. So in this scope of work, the scope of work for this project, I will build a convolutional neural network to classify the traffic side. The dataset is downloaded from the Laboratory for Intelligent and Safe Automobile, which is called a short name ELISA. There is 7,840 RGB image, and then I divide them into 4 different groups, which is a stop sign, speed limit, pedestrian crossing, and other. And the size of the picture is like all the way from down from 6 by 6 pixel up to 168 by 168 pixel. So before that, I'm doing a little bit of the EDA with the data set. And on the right hand side, you can see that there's a class, there's a speed limit, there's a stop sign, it's a very low resolution, um, and uh, and other classes right there as well. The class distribution is, as you can see, there is like there might be a imbalance problem, might be the imbalance class problem here, where you can see this we have a lot of image for the order, as well as but we only have a very little pedestrian crossing image. But for the stop sign and speed limit, we like having like around 1800. I think this is an okay sign for this project. So first of all, how do I have to create my training data sets? So I rescale the image so to make sure that all the images having the same size, the same number of pixels. So I'm going down to 32 by 32, and I range scale them where make sure that we filter out all the red, green, and blue, but just dealing with the single channel image. And after that, I splitting the data set into 80-20 training validation with the batch size of 32. Um, and after that, here is my convolutional neural network. So this is a three-layer neural network where we have the input, and then we put into the first convolutional neural network layer. And then we're doing map pooling, and then fit into the second layer, and doing is another fitting that into um, another conv layer before we put it into a fully connected layer to do the analyze. So the picture here is from I copied this from a Lekan block, but in fact my model structure is more similar to this. So and here is the graph where we have showing them the number of epoch on the x-axis and the accuracy on the y-axis. Yeah, so as you can see that in my case, I a little bit overtraining my data, and you can see that the values and accuracy like drop off below the training accuracy at around 5 epoch. So, and then you have on the right hand side, you also see that the log function that after the 5 epoch, the validation data set have like a higher the logs, the MSE, MSRE. So I feel like I think this is the right number of epoch would be like around 5. So this is where I will tune my model to, like switching the number of epoch to 5. Um, and then I testing that with the real world image. So the real world image, I going out, I take a picture around with the stop sign around my place, and there's some of the pictures I downloaded from Google. I pre-crop it. There is a 80 image cropped image, and then there's a 25% for each class, with like pretty much like 20 image for each class, which is a 25%. As you can see here, it can predict the pedestrian crossing very well. Speed limit, yeah. But I also have a result that where it's showing that the stop sign is misclassed at the order. Here is the accuracy with the real world image is only 55%. I think that the reason for this is the number of my test image is too small, that it did not fully explain the model. So the next step will be I would adding more image for a class, and then I will try to classify more image, like adding more class to it rather than just having a for class. And I will using Current Tuner to tuning the model to getting a better result. And I might be able to use. I'm probably going to use the data augmentation to fit in the data into the model. Uh, so, and the very last step will be like building a traffic side detection model where we try to detect the traffic side in a big image, right? When we have multiple project object, um, and then yes, so that will be it. That is my presentation. Thank you.